اوكي. طيب صباح الخير. النهارده عندنا several small topics that we require to know, but I suggest that you explore these topics more on your own because they are extremely important, especially for those who are going to work on the site and the project management, the construction supervision, and all other aspects that are not related to the design stage. The first topic we are talking about today is cost estimates. The previous assignment that I sent you last week was a general overview of how we consider the cost estimate in order to estimate the fees of the project. And cost estimate is an extremely important topic for the client. They always ask about the cost estimate from the first day. They want to know about the cost estimate and understand what is coming in the future. Yet, the architect has limited responsibility regarding the cost estimate. You are not responsible for the cost estimate as an architect, but you might be responsible if you work for a project manager and you have cost estimate duties. Then you have to provide cost estimates legally and officially. The cost estimate provided by the architect is based on judgment of previous experience, of available knowledge, of familiar construction industry activities. So you cannot warrant the cost estimate that you provide to the client. It's always an estimate, and it's always changeable according to the progress of work and the time of the cost estimate. So it's only an approximate vision of the project, but it helps the client to understand the project budget, which entails more than just the construction cost. It involves issuing permits, issuing licenses, insurance, getting loans from banks. So the client uses the cost estimate for different purposes. There are several stages of the cost estimate that the architect provides. During the concept, the beginning of the project, you provide a cost estimate. After finishing the schematic design or the first project, there is another cost estimate. And after you finish the construction documents and the design details, you provide another cost estimate. It provides a warning of scope creep, monitors changes for the project. But it can also assist the real estate company to understand how to estimate the prices, the leasing contracts in the beginning of the project. So it is a very important number that you provide, and you have to understand how to work on this estimation. So the first method we use is called benchmarking. Benchmarking means that you relate the cost of the project based on the examples of other projects. And for example, when you design hospitals, the benchmarking would be the bed. It will be per bed. The hotel, it will be per key, the room key, not the number of occupants, not it will be by the room key, the number of rooms. For the schools, it is usually by student. For the residential projects, it's usually by meter square. For office buildings, it will be the gross lettable area, not the whole area, the lettable area. So if you have a project that has mixed functions, you have to estimate each function individually and provide an overall cost estimate. The cost plan, as we progress, starts to have a more accuracy. During the preliminary cost estimate, we expect 25 to 30% tolerance. So it is up or down 25 to 30%. During the concept plan, the accuracy will be more, so the tolerance will be plus or minus 15 to 25%. When you finish the schematic design, the first project, the tolerance will be less, will be 10 to 15%. When you have detailed plans and working drawings and bills of quantities, the estimate can be up or down 5 or 10%. So the accuracy increases as the design progresses with the project. The real cost or the real cost estimate will be the cost provided by the contractor according to the tender documents. Yet, this might not be the final cost of the project because there might be variation orders or additional work required or obstructions during the construction that might delay or change the cost of some items. So even during the construction, the cost might continue to change according to the progress of work. So being with a high-level benchmark estimate by function is a good beginning that allows the architect and the owner to understand the scope of the cost. You need to do some adjustments according to some major items like the geographical variation. If your project is in Siwa or in Aswan or in Hurghada, it would be different than projects in Cairo or Alexandria or major urban areas because the distance, the availability of materials, the availability of workmanship will affect the cost of your project. You need to provide accommodation for the workers. You need to provide water for the site work. You need to provide materials, transportation, and all that adds to the cost of the project. So you need to think about a multiplier that is a function of the units in order to accommodate for the changes in the cost. You also need to add contingencies, like 10% contingency to the cost in order to accommodate for any changes or delays. You have to emphasize the tolerance for the client. They need to understand that the cost provided by the architect is not 100% accurate. We think about the tolerance according to the stage of the project. Use resources from the internet or from reputable companies like Leeds, like Bechtel, like big companies that provide Turner. They provide benchmarks for projects from previous years. Yet you have to consider the inflation rate, how the project will not be constructed today. It will take 2-3 years to finish. So during this period, there will all continue to be inflation, and this will be this will affect the project cost. When you have an office, you have to start creating your own database or price book. And this is a very important information that offices keep safe, because it builds up based on their experience and previous projects. In some situations, you might get a client who has a fixed budget. They would tell you, I have budget of 100 million for this project, and I cannot exceed that. So you have to, as we said in the fees, you work top down, not bottom up. You need to see how will you design or provide a project that meets this fixed budget. So it's a very critical point to consider even before starting the programming stage. Is it an open budget or a fixed budget? Because that will limit the number of units or meters square or items that you can accommodate in your project. And it makes no sense, not little, no sense to prepare a program ignoring the realities of the client's budget. So you have to communicate with the client from the beginning. Is he willing to have any budget based on the requirements, or there is a fixed budget they want to follow? So it's always a concern of the client. Clients usually talk about the budget and the cost before they talk about the design. It's very critical for them to know and see that you are concerned about the budget and you have knowledge to provide good cost estimate for the project. Usually clients are over optimistic, and they think that with the little money they have, they can do everything. The client's role is, the architect's role is to correct this view and make them understand how much what they are asking for will actually cost. Because there are many items that they don't understand and they don't consider when they think about the budget. Of course, the cost changes with the building type, the building quality. If you have 5 stars hotel, it's very different than 3 stars hotel, than 1-star hotel, a resort on the coastal area is different than an upgrade of a project in a historical area. is different than a neighborhood design in a desert or outside the city. So this will extremely impact the cost of the project. Also, the construction system that you adopt will affect the cost. Is it a traditional concrete structure, or you are using special construction systems and designs, materials? All this will affect the cost. So when you are developing the program of the project, you have to find this information and arrange for the cost to include all these variations, from the quality to the construction system to the geographic location to the nature of the area. Like a Hong Kong bank, when it was built in Hong Kong, there was no access through the city to the site. So they had to build a tunnel to provide the materials to the site. Sometimes you provide the material by boats. So all these requirements, they affect the construction cost. And it's very wise to confront this problem or this issue from the beginning of the project, so you know that if it's a go or no. Don't waste your time and effort on something that is not going to continue. So from the beginning, client knows what is the budget. Do they accept it or not? Should I go ahead and start the program or not? So don't start without having all these variables clear to you from the very early stage. And as I told you, the first question the client will ask you, how much will it cost? Not how will you design it, or what style are you using, or what. They don't care much about this. This comes second after the cost. So having a cost estimation skill through workshops, through training, through personal study is a very wise step. The client is also usually very happy to see that you understand their concern about the budget and is following it in your work. We need to understand the difference between construction cost and project cost. The project cost is not the construction cost. The project cost is more than the construction cost. The construction cost is just one part of it. Other items include the land price, the cost of providing infrastructure, the cost of issuing permits, inspections, insurance. All these are parts of the project cost. The soil tests, this has to be paid by the client. The contour lines, the topography, surveys, this has to be provided. Archaeological surveys, if you have some historical elements in the site, you need to make sure that they will not stop the work. The feasibility study is done by an economist. The lawyer who is going to review the contracts. Government approvals, taxes, debt retirement, and moving on in, and the furniture and the machinery. Usually the construction cost is like 25 or 30% of the actual cost of the project. The rest is other items that are included or hidden from the architect or not part of the architect's job. The land might cost like 50% of the project cost, depending on the site location, the area, the cost per meter square, the availability of infrastructure, electricity, sewage, water. All these items are very expensive to provide. So we need to be very clear that the construction cost, which is our responsibility, is not the project cost. So building costs, they is one part of the items. Fixed equipment, site development. So this is the total construction cost. Then you add to it the site acquisition, movable equipment, professional fees. Your fees are not part of the construction cost. They are part of the project cost. Contingencies, 5 to 15%, depending on the site location and the type of the project. Administrative cost, if you are going up to hire a project manager. So the total project cost, you need to add all these items to the cost of the construction. This is not commonly understood by the client. So the architect must provide them with a cost estimate analysis, the building, the fixed equipment, and the total construction, and what will be added, and see the difference between the construction, 13 million, to the actual or the complete is 17 million. One interesting item relates to the design is that the shapes of your spaces affect the cost. Assume that you have a requirement in the program to provide a 100 meter square for a item. The shape of the plan makes a big difference because the area might be the same, but the perimeter will be different. And the perimeter affects the cables, the electricity, and the skirting. Anything that is per meter run will be affected. Per meter square will not be affected. The wall area will be different according to the shape. So the wall to floor ratio in a regular item will be different according to the change of the shape. So this is also something that you need to consider in your design. Here we have 1.2 ratio. B, we have 1.74 ratio, and C is 1.62 ratio. And that affects the cost of the materials, the paintings, the cabling, everything that is related to the meter run. So the shape that you select for your design affects the cost of the project. The height of the building is another major variable that affects the cost. The higher you go, you need to think about how will materials be moved from the ground level to the 30th floor. What types of cranes you will need? How will you get the concrete mixture to that 30th floor? How will you get the workers up and down? The safety requirements. So the higher the building, the more cost. You will need vertical transportation, more foundation, stronger structural frame, a fire protection, services, and also accommodate for the wind loads that will affect the structural system itself. And that will increase the cost of the construction. So all decisions, all design decisions, they affect the cost of the project. So cost planning, as we said, that it has a set budget. You go through the concept, the schematic design, the detail, and the cost planning becomes more accurate as we proceed. To adjust the cost, sometimes we do value engineering. Value engineering is a type of activity of workshops that involve the client, the architect, the contractor or subcontractors, if available, and the users, and they discuss ways to improve the quality while decreasing the cost. So it's not only targeting the decrease of cost, it targets keeping the quality or improving it while reducing the cost. And there are many places that offer value engineering certificates, and I think this is also a good step ahead to have these types of certificates. There is also life cycle cost analysis, which is another activity we do, that we study the life cycle of the machines and the materials. These tiles, should we use vinyl or ceramic tiles or marble? And what will be the impact of each one on the quality and the cost? And what is the life cycle of each one? When do we need to replace it? What maintenance does it require? So as they say in the America, I'm not so rich to buy a used car. When you buy a used car, you need to go through maintenance, replacement of parts, and tear and wear of the several parts, and it might cost you more than buying a new car. Also, when you have two options to buy air conditioning system from a country that sells it cheap without naming, and another country that sells it expensive but high quality. It might be wise to get the more expensive than to get the cheaper. The cheaper, you have to read about the maintenance, the requirements of running, the running cost, and you might find that the cheaper ends more expensive after 10 years than the expensive today. So we are saving money in the future, not only today. So these are two areas that I think are very good for you to pursue in the future: value engineering and life cycle cost analysis. They are very important. They target the cost, they target the design, the materials, and they provide professional feedback, not subjective feedback. So the quantity surveyor also has a role when deciding on the quantities of the project, that the quantity and quality defined in the quantity surveying and the specifications affect the cost. And this triangle shows the relationship between the quality, the time, and the cost of the project. They all work together according to the relationship of the triangle. Cost divided by quality and time. Quality by time equals cost, and so forth. So they are all related, and you need to consider. And from the beginning of the project, no money, no project. Have to make sure that the client has the required budget for the project. So time is controlled by the project manager. Cost is controlled by the quantity surveyor, and quality is controlled by the architect. And the three of them must work together. You cannot decide everything alone. You have to work with others. The cost management is a bit different from the US and the UK, even in the terminology. In the US, they call it cost estimator, and in the UK, they call it quantity survey. The approach is led by the program. Here it is led by the design stages of the RIBA, the Royal Institute of British Architects. The cost-loaded programs versus the bills of quantities. In the US, they use the CSI format of specifications. In the UK, they use the PMI, our NRM. The Professional Association for the Cost Surveyors or Estimators is AACE, and here it's RICS. So it depends on where you are going to practice. You have to understand that terminology is different and the associations are different. In conclusion of this cost management or cost estimation, benchmarking is very critical, and it is updated yearly. Every year there is and sometimes every month, there is a newsletter about the benchmarking according to the company. Cost plans are approximate, not accurate. Accuracy improves as design develops. Building shape, size, and arrangement all affect cost. Height, room shapes, sizes, ceiling height, all these affect the cost greatly. That's why we encourage those of you who are interested to go in this track to get some professional training and certificates in value engineering, in life cycle cost analysis, in cost estimation, and project management. These are all important areas for you to consider. That is the end of our first lecture. Now we will go to the next lecture. What? I sent the link. Accepted? I don't. Okay. Yes. Okay. Now we will go to our second lecture. Okay. The second lecture of today or topic will be on time and scheduling, which is very, very much related to the cost estimate topic. Because time also affects the cost of the project due to inflation, due to delays in work and so forth. So design scheduling targets the phases of production from conceptual planning to the start of construction and how to manage the manpower, the resources to achieve economical, functional, and harmonious design. This is, of course, the first part that you do in the design scheduling. Schematic design is the most difficult to estimate because it can take 1 week, 1 month, or 6 months, depending on the approvals by the client and the discussions and the information provided. So it's very variable. It also depends on the size and complexity of the project, the quality and completeness, decision-making abilities. This is important. Do you have a personal client, one-person client, or you have a committee, or you have to get approval from a council? So you need to, that might take more time. So design schedule, like this is a simple bar chart. You might take 2 weeks or 2 months, and client approval might take 1 quarter. Design development 2 to 4. Client approval, hopefully. Come on, these stars indicate that this is an open-ended part because it might take more. And then the construction documents and the bidding and negotiation and the plan check to start the construction. Client approval time may be longer depending on the type of client that you have. But this is a general view of your design schedule. Now we move to the construction scheduling, which is a bit different because it involves more items, more activities. We use, as we said last time, professional projects like Primavera or Microsoft project to provide that based on CPM or critical path method. It requires involvement of everyone, contractors, subcontractors, specializations, and so forth. The furniture, the equipment, and so forth. So basic considerations include the construction documents. Are they well done or poor? That might affect the construction time because you might need revisions and approvals back and forth. The architect engineer, more or less demanding. The subcontractors, they need to provide coordination. The contractors organization, how big is the contractor's firm? How sophisticated, their previous experience, and so forth. Material dealers, this is a major issue because your work might stop just because the material is not available. I don't have the tiles. I don't have the full ceiling. I don't have the projectors. so the work will stop. So I need to plan ahead and make my orders ahead of time for especially the large items, the large materials. Size and complexity of the project, site conditions, the size of the project, the accessibility. As we said, some projects or some lands, accessibility is a major concern and requires time and expenses. The weather, are you starting construction in the summer or the winter? Do you have snow? You have rain? You have sandstorms? So you need to understand the impact of the seasons on the construction. The labor troubles, are they available or not? How many vacation days do they take? As you know, in Egypt, you have to adjust the calendar with the months of Ramadan. When is it coming? The workers will be very slow during the months of Ramadan. They leave 1 week before Eid, and they take 1 week in Eid, and they come 1 week after Eid. And how many? And also in the Eid al-Adha, they also have to go to their families. So they take 2 or 3 days before, and the Eid takes 1 week, and they come 1 or 3. So you have to adjust your calendar to this. Basically, you have 52 weeks. So you have 52 days vacation out of the 365. Add to them the religious vacations, the national vacations, all types of vacations that we take. They will end up approximately 100 days. So you have almost 25% of your year is not active. And you have to accommodate for that. If your construction schedule will take 4 years, so you have to see when will the vacations be and how will they affect the work. You don't want to start pouring concrete and then Eid comes. So you need to adjust the timing of all these activities. So the bar graph, as you said, is the easiest type. Start and finish dates of major phases. They don't indicate relationships, but so that they require update all the time. So you might have one bar chart and you are updating it based on the actual progress. The CPM, the critical path method, is an interactive, intelligent scheduling that accommodates these changes automatically with any dependent activity. And it's widely used now in the market. This is a simple bar chart. As you see, it's static, doesn't change. It shows start and end of each item. So you might need to update it frequently based on the actual progress of work. This is another type of bar chart. And the CPM method, as we said, depends on the path of the activity, not only the existence of the activity. And the critical path is actually the longest path that the activity might take. So let's see, you have activity 1. It's we call it an event. And from 1 to reach activity 2, event 2, I need to have activity. Like event 1, I will bring the door, and then I need to prepare the opening. and then I install the door, and then I need to go to C, to 3 and 4, depending on the type of work. So I need to get the glass, I need to get the paint. So they can work together after 2 in order to reach 5, which is the end of the event. Okay, to get the glass, I need 2 days. To finish the paint, I need 4 days. So actually the critical path is not the 2 days, it's the 4 days. So the event requires 4 days plus 4 plus 3 is what? 11. This will finish early. So I need to consider all these activities that are required to finish this event. This is how is it called in the CPM language. So for more complex events, you can start, evacuate, drill 5, set pier steel, 4 piers, set formworks in order to reach the end. So to do this, I don't need to wait for these. I can go from 1 to 5, but this must be done. So depending on the activities and how many days they need, I can choose the stage that I need. So let's say excavation needs 1 day or 1 month, and then the drill piers 1. So I have 1, 1, 1. To construct footing forms, I need 2 days. But in order to go through 1, 2, 3, 4, I need 4 days. To set the forms, I need 14 days. And then I need 1 and 1. So the critical path, some people get confused that the critical path is the shortest path. No, it is the longest path, because there are certain items that I cannot do unless the previous items are finished. So this is how it shows in the program. Each item is linked to the elements that it relates to. I cannot bring the painter before I finish the door. I don't need to bring the glass if the door is not installed. So all of these are related to each other. So that is applied to all activities in the project. And if there are changes in any time or resources or material, you go change it in the project software, and it changes everything automatically. It's very important for the fast-track scheduling. Fast-track delivery requires very close scheduling and monitoring by the architect, the engineers, the client, and the contractor. And the CPM can be shared on the internet by everyone involved. And it can also include on-site cameras that monitor the actual progress of work. So in your office or through your mobile, you can witness the pouring of concrete, the installation of materials, and you adjust the schedule accordingly. Is this item done or not? Is it delayed? Delayed for what? And so forth. So it requires close observation to correct errors frequently. Um, um, Design bid build also requires a special type of scheduling that overlaps the design and the construction, so that I can improve the quality by shortening the time. So from the beginning of the project, you have to start establishing the schedule, use CPM, think about the floating items that can change in time, follow the project calendar, the vacation times, expected behaviors of labors and construction, expected weather conditions, snow, ice, rain, sandstorms, extreme heat, like in the Gulf area. They have to consider the hot months of June, July, August. If temperature reaches 50 degrees, then the work stops by law. So you have to consider that there might be some delays during that period. In the US and Europe and places where they have snow, they have to consider snow time or a tornado season. All these are can affect the project. Fabrication times should be considered. If you are requesting tables and chairs, they will not be ready to purchase. You need to order, and you need to estimate how much time do I need to fabricate 1,000 tables and 2,000 chairs for the university. So I need to plan ahead in order to finish on time. A sequence of construction trades. This is a major understanding for you, so that's why gaining a practical experience in the site is very important to be a good designer and a good manager, so that you see things by yourself and see how long does it take for the plumbing to be installed, for the electricity to be installed, for the air conditioning to be installed, and how will this affect the scheduling. Okay, that's the end of this topic. And now we will move to the last topic of today, which is the end part of our work. Okay. The last items that we need to consider is your relationship with the contractor through the shop drawings, site visits, and project completion. First, shop drawings. Shop drawings, as we said, are drawings developed by the contractor based on your working drawings. Working drawings that are 1 to 100 are not sufficient for construction. They're only guiding the contractor. They take these drawings and develop shop drawings for each item with larger scale, can reach 1 to 10, 1 to 5, 1 to 1, whatever it takes to provide detailed drawings that we call shop drawings. They also have to provide samples of materials, and the architect must approve the samples. You must sign with a marker the samples that you approve. they will provide you with samples of colors you have to approve in writing. Okay? So all these are submitted by the contractor during construction, and the architect is required to review, make sure that they comply with the original working drawings, sign, and send back to the contractor within few days. So you have to finish them quickly, otherwise the contractor will request extension of time. So the shop drawings will identify exactly what each item will be, where each item will be installed, the tiles, the materials, the fixed furniture, and the details of them, and so forth. طبعا these drawings and samples, they enable the architect to see whether the items selected by the contractor meet the design intention, and make sure that they follow the construction documents provided to the client at the beginning of the construction. So the contractor must call the architect's attention to deviations or problems in the site construction that are different than the construction documents. And the architect must give specific written, not verbal, approvals. Everything must be in writing, because usually projects, they end up in court. The contractor asks for extension of time or extra money or variation order, and most of the time there are certain disagreements and problems at the end of the project. So protect yourself by having everything signed and documented. Keep records of every paper you signed. Make a copy, and not digital, copy, photocopy. And keep good records of your work. To allow the contractor to deviate from the requirements of the contract documents. Record keeping, as I said, is very important. You have to keep records of every event or meeting or document that you sign and send to contractor, with the dates received, the date returned, the action approved, corrected, revised, refused, and retain copies of all submittals. This is very important to protect your future. Within timelines, within a reasonable time, 10 working days or 2 weeks maximum to return the documents. And if there are changes ordered, they must be processed through formal requests. You don't just go to the site and, no, close this door and move it to the middle. Cannot do that. This is a change order. If it's here in the drawings, then it must be here in the drawings, unless there is a change order. Site visits. Site visits is part of the role of the architect to make sure that the project is progressing according to the contract documents, and the quality of work is acceptable and to the standards, and according to the contract documents. And site visits are also recorded through reports, written reports. So you need to start by having a pre-bid meetings with the contractors, pre-construction meeting with the selected contractor, and during construction, there are frequent meetings. You have to learn how to conduct a meeting because you will be the leader of that meeting, how to record the meeting. What do we mean by M of M, minutes of meetings, how to record the meeting, the activities, the decisions, who attended, when did it start, when did it finish, what were the topics discussed, and what were the decisions taken, and what is the required action before next meeting. So minutes of meetings are very important. They are an extremely important record for the future. During construction, you are required to visit the site, and every visit, you have to write a report. What did you see? What did you approve? What you don't approve, and so forth. You can have what we call interval meetings. These are meetings that are done on intervals, or you can have a pre-established schedule for the meetings, or you can have continuous presence in the site through representatives and junior architects. So you need to advise the owner if the contractor is performing the work in accordance with the contract documents. Meetings, participate in all the meetings, documentation of the meetings, and this might reduce the possibility of misunderstandings. Everything should be recorded. Everything should be shared online. You can have the documents through a network with the contractor, so you can go back to any document at any time or any drawing. And there are many programs and platforms that provide that. Pre-bid meeting is very important. You meet with all the contractors that are interested in the bid and clarify any issues regarding drawings, specifications, bills of quantities. And there is pre-construction meeting with the selected contractor. And there are meetings, frequent meetings during construction and site visits with the contract. Safety, as they say, is number one in sites. You have to make sure that the site is safe for the contractor's workers, for the passers-by, for the community, for the cars. Any accident will cause a lot of damage to the project, to the architect, to the contractor, and everyone involved. That's why we always say safety first. You have to wear the gear, helmets, boots, appropriate clothes. You have to have professional induction into the site. Don't let anyone just go and move through the site. And if you find any problems or observations that are dangerous, you have to inform the owner immediately in writing, and don't ignore, because that might result in the loss of life of someone. The architect should refrain from subjective opinions. Any opinion regarding the project must be based on evidence and drawings, specifications, bills of quantities. Don't just say, I don't like this door, change it. This is not acceptable. You have to say that this does not comply with the specifications or the drawings. Of course, there will be claims and disputes between the owner and the contractor, and the client has a role to look into this regarding cost, time delays, conditions, and the architect should provide professional opinion regarding this. Rejection of work if it does not comply with the requirements of the contract documents. This has to be done through the owner. You inform the owner that the work is not acceptable, and the owner is the only one who can reject the or stop the work. Don't just go to the site, no, stop the work. Cannot do that. The contractor will not listen to you. You have to inform the owner, and he's the only one who can do that. Some tests are required in sites, concrete tests, material tests. They have to be performed in professional laboratories by professionals who provide reports about the quality of concrete, the quality of paint, and other inspections of machines, and so forth. So many universities, they have approved laboratories to provide reports on material testing, and especially concrete mixtures. They have to be tested for all the concrete before pouring, and welding. If you have steel construction, all the welding must be tested and approved. If you go to the site, you see that they may take a sample of the concrete and put it in a conical shape, and then they tilt it upside down and see how what is the amount that it will set and change its shape. So everything must be done properly. Soil tests are also sometimes required during construction, and you might find that the original soil tests were not enough. You might need more. Concrete and welding are usually tested, and after you finish all that, there is project completion. Thank you. The project is complete. This is a very rewarding time. You have to inspect the work completely, make sure that it is suitable for occupancy by the client. Of course, the owner wants to occupy it quickly, and the contractor wants to minimize any remaining work to leave the site. And this is the job of the architect, to make sure that everything is complying with the construction documents. So there might be a stage called substantial completion, where the project is almost finished for the owner to start using it. But then there will be final completion, that all types of work are finished, and the certificates of payments are issued to the contractors, and their letter of insurance is returned, and everything is set. So substantial completion means that the project can be occupied partially or fully by the owner, but the architect must provide what we call a punch list. Go through the project. This wall needs to repaint. This tile needs to be changed. Everything that you see not complying with the contract documents, you must provide as a punch list and send it to the contractor. The contractor must clean up the site and facilities before leaving. And if the owner chooses to keep the contractor for other work, they can do that. And then the occupants come in and start use the site and the project on their own, partially or completely of the project. So the final payment is paid to the contractor, and if everything is okay, and then it's end of the project. And thank you very much, and wish you all excellent future in the profession. And you have all roads open. You have many skills that you need to advance and learn more. What you have learned in the university is just a starting point. You are starting to learn. This is what your certificate will indicate. It's not the end of learning. This is the beginning of learning and the beginning of your career. Thank you very much, and wish you all the best.